figure 4.15c in the solenoid concept. So if you see here, you can notice that the current is going outside and down it is going inside. So how you can, from this what you can infer? What do you mean by this line? This line shows that it's a current carrying conductor, am I right? The center line that's along the axis, always the center is the axis, am I right? The center part is the axis and the current carrying conductor along the axis, if you hold it through your right hand, okay, you are holding it through your right hand, current carrying, straight current carrying conductor, you are holding it with the help of your right hand, and this thumb shows the direction of current, am I right? Thumb shows the direction of current, and the curled finger, how it is curling, can you see? While I am holding this current carrying conductor, first whether it is coming outside, yes, if you are holding the current carrying conductor, it is coming outside, and then only what is happening, it is going inwards. At first it is outwards, then it is inwards. Okay, like this only we will hold the current carrying conductor. While you are holding the current carrying conductor, Ritesh, listen, I will explain it. At first it will move outwards. Okay, first how will you hold? If it is a current carrying conductor, first I will hold it upwards, am I right? Then downwards. So that only I can hold the current carrying conductor in my hand. Okay, and the thumb shows the direction of the current. Okay. Can you understand this? Why they have given dots and cross here? It shows that field is outwards and here field downwards. Understood, no? Yes? So the next one, can anyone say Ampere's circuital law, what we have discussed yesterday? Ampere's equation form alone you can say. Closed line integral b dl equal to mu naught times I inside, am I right? This is closed integral, okay, closed line integral b vector dot dl vector, that is equal to mu naught times current inside the surface, okay, and we have discussed that this Ampere's circuital law very well works for symmetrical shapes, okay. So that yesterday we have considered a circle and we have discussed, am I right? So here in this figure I am going to consider a rectangle. Whether it is symmetrical in shape? Yes. So let me draw a rectangle that covers all the part of this solenoid, okay. Consider this as A, B, C and D. Okay. Can you see the part AB is along the axis that is carrying the current carrying conductor, BC perpendicular to the current carrying conductor, and CD is totally outside of the solenoid. Okay. So current flowing outside the conductor, whether we can consider in Ampere's circuital law? Yes, we are not even considering, and that too, since the field is very weak, field outside the region is 0. Okay, B vanishes. Yesterday we have studied, am I right? 3 rules under Ampere's circuital law. Take your book and go through. The first point, which is along the axis which is carrying the current, okay, and the second one normal, B normal, and third one B vanishes. So for covering all the 3 points, here I have drawn a rectangle to explain all this. Okay. So So how can I write this means? I can expand this single law into B vector dot dl vector for AB, for BC, closed integral B vector dot dl, and for CD again B vector dot dl. Then remaining part will come next one. AB I have written, BC, CD, then next one DL. Closed line integral B vector dot dl vector. Okay. So if you see BC, it is, you take this small element, okay, consider this small element, whether this small element is perpendicular to the current carrying coil, where we have placed it on the axis of the solenoid, okay, then it will become 90 degree, am I right? So B vector dot dl vector, if I want to write it in scalar form, how can I write? Yes, written as B dot D dl dot product, then it will become cos theta. So what is theta here in the case of BC? 90 degree. So it will become B dl cos 90 degree. What is cos 90 degree? It's 0. So it will become 0. Okay. So this term totally it will become 0. Understood? BC totally it will become 0 since it is normal to the axis. Okay. What about CD? Outside the surface there is no magnetic field, so it will become 0. Then again what is DA? Again if you consider a small current element DL, again it will be normal, that is 90 degree. So B DL cos 90 degree, again this term will also get value of 0. So coming to this, why I have left this for discussion is, here we have to work it out, okay. So that only the remaining 3 I have discussed it at first. So AB, if you consider this, it is along the axis, okay. So what is the angle made by AB part? It's 0, am I right? It is 0. So cos 0 degree in this case for AB is AB alone, cos 0 is 1, so it is BL, am I right? B, very good. So it will be B. So here how can I write this? B, that is equal to, according to your circuital law, that is equal to mu naught times current enclosed, current inside the surface. So our final formula will be B vector dot dl vector equal to BL, that is equal to mu naught times current inside the surface. Here the surface is rectangle, okay, which contains symmetry. Next, a small assumption, okay, but it's the truth only, okay. So what do we mean by N? N means number of turns per unit length, am I right? Solenoid means circular turns, so many circular coils wounded in the form of a helix, am I right? That is your solenoid. So N is number of turns per unit length. And can I write number of turns in length L is equal to N into L? N is the number of turns per unit length, okay. So where NL is the number of turns, total also you can say, in length L, because we know that this wire is of not finite in size, okay. Anyway here solenoid, with what assumption we are conducting, we are carrying the discussion means this D is very smaller, am I right? Comparing to the length, this length is very greater than the diameter of the solenoid. With that assumption only we are carrying out this. Okay. So number of turns in unit length. If you take a particular length, so what will be the number of turns? That is your NL. Okay. Next I am going to substitute here. This NL I am going to substitute here. Number of turns in length here. So what it will become? DL equal to mu naught NL I inside. Right? Can I cancel this 2 L's? Yes. So what is the resultant equation? That is equal to V equal to mu naught NI. Where B represents the magnetic field, mu naught represents the permeability of free space in vacuum, and that value is equal to 4 pi into 10 power minus 7, and N is the number of turns per unit length, where I is the steady current that is flowing in the solenoid. Okay, the current what we are discussing is steady current but not fluctuating. Any doubts? Any doubts?